And so there's two types. So we looked at just general sequences on Monday, and there's two specific types of sequences that we're going to look at. In 8.2, we're going to look at arithmetic sequences. That's how you pronounce that word. It's not arithmetic. Arithmetic is a noun. Okay, when we use this word as an adjective, because it describes the sequence or it describes the series, we say arithmetic. Okay, so here's the thing that you need to know about arithmetic sequences. First off, here are two examples. Two examples of arithmetic sequences. And you don't have to write all of that down. But I'd write the first, 4 or 5 terms down. Because there comes a point where you kind of get the gist, right? You kind of see the pattern. On this first one, what's the pattern? Plus 3. Adding 3 every single time. Okay. What's the pattern on the bottom? Minus 10. So another thing that we can say is that we're adding negative 10. Of course, that means the same thing. So when the pattern is like that, that's arithmetic. Okay, so when the sequence goes up or down by the same amount when adding. That's the key, when adding. Obviously on the bottom we could say subtracting. But when we add a negative, that's adding the same amount. Okay, so it's an arithmetic sequence when you add the same amount every single time to get to the next term in the sequence. That's what makes it arithmetic. So in this section, we're going to be looking at sequences that are generally arithmetic, or we're going to determine if they are arithmetic. Now, if they're not, they can be a perfectly fine sequence. They just aren't that specific type. Okay? So this is the general kind of form of an arithmetic sequence. So remember, when we put it in set notation, that means all of the terms in that sequence. So our first term is a sub 1. Okay. What we're really getting to here is that amount that we add every single time is called the common difference. And it's signified using the letter D. And the reality is the difference between each term is what we're talking about. All right, so to get to the second term, you take the first term and you add the common difference to it. To get to the third term, we take the first term and add 2 common differences to it. Another way to look at this, and I added this in here, is that basically this term here is a sub 2. This term here is a sub 3. This term here is a sub 4. And this term here is a sub 5. So notice the pattern in terms of the number of common differences that get added. Right? So like for example, on the fourth term, how many common differences get added to the first term? So the fourth term, how many common differences do I add? 3. Okay. For the fifth term, how many common differences do I add? 4. So the number of common differences that you add to the very first term is always going to be 1 less than the term you're looking for. So if I was looking for the 8th term, I would add 7 common differences to the first term to get me the 8th term. And what all this is leading to is the formula. Okay? In order to find the common difference, like sometimes, like those 2 examples that we talked about, they were obvious, right? We added 3. We added negative 10. Sometimes they're going to be fractions or they're going to be decimals. So if you can't just look at it and see, the way that you find the common difference is just take 2 consecutive terms and subtract them from each other. So that's all that this is. Take a term and subtract the one that came before it. And that gives you what the common difference is. Like I said, most of the time you're going to be able to see it and just know what it is, but sometimes it'll be fractions or decimals and it'll be a little tougher to find. Okay? And again, like I said, what we're doing is getting to the formula. The formula for any term in the sequence, a sub n equals the first term times n minus 1 common differences. So again, back to the idea is, if I'm looking for the 20th term, I have to multiply it by 19 common differences. So that's why you see the n minus 1. And that'll get you that term without having to find the first 19 terms. And then the last piece to this, we can also write it recursively. We talked about recursive formulas before. So you have to know the first term. Okay, so you have to identify the first term when you write a recursive formula. But for any term, you take the nth term is going to be the term before it plus the common difference. N has to be greater than or equal to 2. Because if it's not, then this ends up being 0, which we can't have. So that's why we have to specify. So when we're going to be defining recursive formulas here, you need to have all of this as part of your formula. So there's a lot more to write. You have to identify a sub 1. You have to qualify it by saying n has to be greater than or equal to 2. So when we get to a recursive formula, just know that we're going to have to do all of that. So here are two examples. So here's the first one. One of the things that you're going to have to do in your homework is determine whether or not the sequence is arithmetic. And if it is, then you identify the common difference. So go ahead and write those two down, and then decide if it's arithmetic. And if it is, then state what the common difference is. Go. First one, arithmetic or no? What is the common difference? Negative 10. Okay? So every time, and the way you check, you just look. This one goes down by 10. This one goes down by 10. This one goes down by 10. So yes, this is arithmetic. The common difference is negative 10. Okay? How many had that? How about the next one? Is it arithmetic? 4, 5, 6, 7. No, it doesn't change by the same amount. So this is a no. Okay? If it changed by adding of the same amount every time, then it would be arithmetic. Okay? So that's part of what you're going to have to do in your homework. Questions on that? Pretty straightforward, right? Is that the same? Yeah. I guess I didn't do it. So here are some other kinds of problems that you're going to have to do. I don't know why it's there twice. So part A, write the first 5 terms of an arithmetic sequence with the first term, negative 5, common difference, 4. Then we're going to write a recursive formula. Okay, so in this case, the first term is easy, right? They gave it to us. So what's a sub 1? Negative 5. How do I find, because I want 5 terms, a sub 2, a sub 3, a sub 4, a sub 5. How am I going to find the next term? Add 4. So what do I get? Negative 1. How about the next term? What do I do? Hello? Add 4. So what do I get? What do I get for the next one? 7. What do I get for the next one? 11. Okay? That's all you got to do. Add 4 every time. So it'll look like that. Okay? Now let's talk about the formula. Okay? So we have to do several things for the formula. We have to say what a sub 1 is, which is negative 5. So that part's done. We have to say that n has to be greater than or equal to 2. That has to be there too. So I'm saying a sub n. What are we really doing every time? We're taking the term before and doing what to it? Adding 4. So then I just take a sub n minus 1, which is the term before, because whatever the term is, a sub n, the term before it is a sub n minus 1, and then I add 4. That's it. There's my recursive formula. It has 3 parts to it. It has the first term. It has the actual formula. And then it has the condition. So again, the general formula, the only things that change is whatever the first term is, whatever the common difference is, all the rest of it underlined here in blue is the same. Okay? Any questions about that? Let's look at another one. Another kind of problem. That's what we're going to be doing today, is going through most of the examples. So finding a specific term of an arithmetic sequence. In this case, they want to know the 9th term. They give us the first term, and then they give us the 22nd term. They don't give us anything else. All right. What do we need here? What do we need to know? Do we need A2, A3, A4, all the way to A21 to fill it in? Do we need to know that? No, we don't. There's a way to do this without. Because the only piece that we need, if you think of the formula, is what's the missing thing here? What don't we have that we need? The common difference. Okay, we need that common difference. Okay, and that's what we need to find. We need to find that common difference. And since we have another term besides the first term, we can find the common difference. This is the key to the whole thing. Because if we think about the arithmetic sequence formula, I need the first term, I need to know n, the number of term I'm looking for, and I need to know the common difference. Well, I can use this to work it kind of backwards. Let's think about what the formula is again. Okay, this is our formula. A sub n equals the first term plus n minus 1 times d. Now, I can substitute in 22 for n, and I know that the a sub 22 is 164. And I know what the first term is too. So that can help me find the common difference. So here's what that looks like. Okay, so I plug in the 22 because we already have this. So a sub 22 has to equal the first term plus, since n is 22, I put the 22 in, minus 1 times d. So I have an equation.
Wait, why don't you plug -4 in for it?
Yeah, no, I'm going to do that here in a second. Okay, so I'm doing it just generally. So right, not only am I going to plug -4 in for a sub 1, I'm going to plug 164 in for a sub 22. Okay. And so long as I'm given the first term and I'm given some other term, I can use this to find the common difference. Okay, so now I'm going to plug in. So 164 for a sub 22, -4 for a sub 1. Now go ahead and finish it. Solve for d. Okay, so what's d? 8. So I go through, solve, combine, d equals 8. Right? Is that it? All I got to do is find 8? We're trying to find the 9th term. So now I go back to the actual formula. Right? My first term is -4. I know the common difference. And which term are we trying to find? The 9th. So what is that? What's 9 for this? N is 9. Let's do it this way. Let's just plug 9 in right now. Right? A sub 9 equals -4 plus 9 minus 1 times 8. Extra parenthesis for no reason. Alright? So A sub 9, I want to keep writing a G. 9. All of a sudden I can't write a 9. There we go. This is -4 plus 64. That equals 60. Okay. So I plug. Oh, well, I guess we could plug it in after. Why would we do that? What I did was actually simplify it first and then plug 9 in, which you do. Either way, you get 60. Either one of those work. Okay? So that's how you find a term when you're not given the common difference. You have to be given another term, though. Now, there's another situation that will come up where you aren't given the first term. So that gets a little tricky. No, it's not next, but it's coming. We'll get there in a second. Okay. The next thing is, if I've given a certain sequence, but we don't know how many terms there are, and we're going to find the number of terms. So look here. We don't know how many terms there are. We know 7, 3, -1, -5, and then The last term is negative 113. We don't know how many are in between here. Do we know the common difference here?
-4.
-4. Okay, so that's going to be helpful. So what we're going to do. So what we're going to be doing now is solving for n. Okay, we're going to solve for n. And here's what we have so far. We know that the last term is negative 113. We just don't know what the n value is for that term. We know the first term is 7. We still have our formula. And we know the common difference is negative 4. So long as I have the last term of the sequence, I can find n, and that will tell me how many terms there are in the entire sequence. So go ahead and solve this. Finish this, find out what n is. Now when you're working on your homework, you're going to want to have these notes because there's like an example for each kind of problem that you're going to have to do, and you do something a little bit different each time. Who's got n? Raise your hand if you got n. Ellie, what do you got? 31. Is that what you got? The rest of you guys got 31? Okay, good. So let's look. So go ahead and solve, distribute the negative 4, find like terms, n equals 30. So there are 31 terms. Good job. Okay. Now, here's the next example I was talking about a second ago. That's a little trickier. Okay. In this case, they want the 500th term. Right? We certainly don't want to find 500 terms. In the example, the 2 examples ago, they gave us the first term. The problem here is they don't give us the first term. Right? So we still don't have the common difference. If we had the common difference, I could find it. But I also need the first term. So I have to figure out a way to find the first term. And that's where it gets a little tricky. Right? So since they give us this, the 15th term is 49 and the 27th term is 85, we have a couple things so far. All right, we can use, and you don't have to write all of this down. We're going to actually set up a system of equations. Sorry. Because we have to solve for a sub 1, and we also have to find d. So we don't know the common difference, and we don't know the first term. If we had those things, or one of those things, the problem would be a heck of a lot easier. But because we have 2 things that we have to find out, we're going to use this and this to come up with a system. And essentially what we're going to do is we're going to plug a sub 15 in, and we're going to plug 49 in for that, and 15 in for n. And that'll give us one equation with a sub 1 and d. And then we'll do the same thing with a sub 27 and 85. 85 will go here, 27 will go there. And that's where my system of equations will come from. So let me show you what that looks like. All right, so we're just substituting in, again, here's what I have. So for this first one, a sub 15 is 49, so a sub 15, so that means n is 15. For the second one, this means n is 27, but a sub 27 is 85. So here we go. Let's look at this a little bit. Here's my system. Hold on. So let's write this out a little bit more first, and then I'll have you solve it, because then you can solve it. So I know. This is 49 equals a sub 1 plus 14d, right? And this one is 85 equals a sub 1 plus 26d. So take that and solve that system. Okay? You just got done doing this in chapter 5. 49 equals a sub 1 plus 14d, and 85 equals a sub 1 plus 26d. Solve that system. Solve it for a sub 1 and solve it for d. And then once we have those 2 things, we'll be able to find the 500th term. So go. So after, okay. Oh, here's what you should have gotten. Here's all the little steps in here. Okay. Multiply by negative 1. Either one. D is 3. First term is 7. How many had that? Okay, good. So now once we have the first term and we have the common difference, we have enough information to find the 500th term. Okay, so now I'm going to just put that in.
That's just
All that work makes it look harder.
Yes, it's very overwhelming. So here's our formula, right? The first a sub n, okay, the first term is 7, the common difference is 3. But I'm trying to find a sub 500. Let me slide this up a little bit. Okay, so since I'm trying to find a sub 500, I plug 500 in for n in my formula. Remember that it's always the first term times the common difference. So in this case, I take 500 minus 1, which is 499 times 3.
How did you get a sub n equals 7?
A sub 1 equals 7.
Oh, okay.
So again, the formula is right here. Here's the formula, the general formula, right? So you need the first term, you need the common difference. So that's what we did here. The first term is 7, the common difference is 3. And then when you're looking for a specific term, you just plug that number in for n. So a sub 500, 1,504. That's as hard as they get for this kind of thing. You want to have either common difference or the first term. If you have that, these problems are a lot easier. But sometimes they don't give you that. Sometimes they only give you 2 specific terms, and you have to find those things. And that's when that happens. That's when there's more work.
So, is this whole bottom part right here, like all the words and sentences, is that like an answer that we have to put?
No, you can just. This is an explanation.
So we can just.
You can just go right to here. You can go right to here. Yeah.
I was gonna say.
Once you have 3 and 7, then you can go right to here. You don't even necessarily need to write out the formula this way. It's the general for that specific sequence. You can go right to here. That's fine. Okay. So yeah. So now we haven't even talked about series yet. So series is take the terms of a sequence and add them all up. So now we have to talk about that.
So just hit the plus on your calculator.
No. You want to do that for 500 terms?
Yep, I will.
No, please don't do that. I'm going to show you a much nicer way. Okay. All right. So let's talk about series. So this is so we talk about evaluating, so finding the answer to a finite arithmetic series. That means there's a specific number of terms. Okay. In this particular case, our sequence is 1, 4, 7, 10, 13. And the sum of the first n terms of a sequence is called a partial sum. Okay, also known as a series. And it's indicated here by S sub n. That means a series or sum, nth partial sum of that sequence. Now, this one's super easy, right? Absolutely. You could probably just add these up in your head. Okay? Or if you really wanted to, you could punch them in your calculator. And we're going to use this super simple sequence to demonstrate how we can generate a formula and use it for something a little bit bigger. So, in this case, I can find all these different. So if I wanted to find the partial sum S sub 1, that's just adding one of the terms together. If I wanted to find the partial sum S sub 2, then that's adding the first 2 terms together. If I wanted to find the term for S sub 3, what would that be? Which is how much? 12. So partial sum S sub 3 is just 12, because it's the first 3 terms added together. Okay, find S sub 4 and S sub 5. What's S sub 4? 22. And then S sub 5 is 35. So it's just different partial sums. Now, it would be a lot easier to find S sub 5 if we had a formula instead of adding all those things up. So So let's show you where this formula comes from. Now, what I'm about to put up here, you can write down if you want, but it's not something that you need to know. It's a derivation of the formula, okay, and where it comes from. So I would encourage you not to write it down and just to pay attention, because you don't need to know it. I just want you to see it and understand where it comes from, okay? So look at the screen, listen, and you'll see what's going on here, okay? For large numbers of terms, adding them would be really cumbersome. It'd be a real pain. We don't want to have to do that. So I'm gonna show you the where this formula comes from. Basically, what they're gonna do is we're gonna write the sum for the first 5 terms. This sum, S sub 5. We're gonna write them like this, and then we're gonna reverse the order and put them both there. So here's as it is: ascending, they go up; descending, they go down. Now notice what happens if I combine them together. What do I get all the way down? 14, 14, 14, 14, 14. And I get 2 of this S sub 5. Right? Well, this is 5 14s. Right? It's the same thing as adding them up. Now, if I want to get that partial sum by itself, I would get 35, like we already have. It's fine. But notice what we did here. Okay, we took this sum, we multiplied the number of numbers times this sum of those and divided it by 2. So here's what, go back and look. Okay, formula comes from. Here's the formula. Okay, you take the first term and the last term, add them together, multiply it by n, and divide by 2. So if we think about what the first term was, because the sequence was 1, 4, 7, 10, and 13. So if I take the first term, add it to the last term, I get my 14. Multiply it by the number of terms and divide it by 2, and I would get my same partial sum without having to do the individual addition. Okay? So that's what this formula is really good for. Here's the last example we're going to look at. So again, find the sum of the first 50 terms, right? Well, in order to use the formula, I need the first term and I need the 50th term. If I had that, then I could finish this. But they only give us the first 5 terms. So I'm going to have to find the 50th term. There's my formula for partial sum. We just need a sub 50 because we know everything else, right? In this particular, to find the partial sum, the only thing I need is the first term and the last term and the number of terms. How many terms are we talking about here? 50. So how am I going to find a sub 50? Yeah, so we had a formula from before to find the 50th term. I know how many terms there are, 50. What's the common difference? 2. Find a sub 50. Go. And just a reminder, you need this formula to find a sub 50. Okay? So take a look at the screen, see if you had it set up right. Okay, a sub 50, the first term, 50 minus 1, because it's looking for the 50th term, so that's n. Common difference is 2. How many had that set up right? Right, so what does this equal? 100. Okay, so that's 49 times 2 is 98. That's 100. So now I have everything I need, right? I've got the 50th term. I've got the first term, and I know how many terms there are. So let's look at the partial sum. So here's plugging it in. Now this way that the book did it is a little different than the way I did it. Either way we get 100, it's fine. Okay? So what is this?